All right. So we always talk about logarithms right after we talk about exponential functions because they're inverses of each other. So the logarithm base b function written log base b of x is the inverse of the exponential function b to the x. Right, and we'll come back to that kind of at the end of the lesson and use properties of inverses to figure out some things. But if we have b to the a equals c, it is equivalent to the statement log base b of c equals a. All right, so the big base from the exponential form becomes the little base in logarithmic form. Right? What it equals in exponential form moves across the equal sign, and that's called the argument. And then a logarithm is always equal to a power or an exponent, however you want to say it. Okay, so the first things we're going to do is go back and forth between exponential and logarithmic form. And in Algebra 2, your teacher may have shown you a loop to do it. I used to do that when I taught Algebra 2 also. So you can draw this loop if you want to. All right, so that in logarithmic form, log base b of 1/8 equals -3 turns to 2. So we start with a base, but it becomes a big base, raised to the -3 equals 1/8. Do you guys think that's true? 2 to the -3 is 1/8? Yes, because what does a negative exponent mean? Reciprocal. So you just flip it over and then do 2 to the third on the denominator, and it gives you 1/8. Okay. Now this new textbook uses, instead of using numbers, they use a lot of variables on this lesson, which is fine. We can still do the loop. So the base g becomes the big base, raised to the j equals h. All right, we're going to do it the other way. So we have it written in exponential form. We're going to write it in logarithmic form. So when you write in logarithmic form, you need to make sure you start with the word log. And the big base becomes the little base. Oh, we can still do the loop if you like it. So the big base becomes the little base. All right, the 81 hops over to the other side, and it equals the power, or it equals the exponent. All right, you guys try B on your own, please. All right, what'd y'all get? Good. Log base 4 of t equals r. All right. Now he mentioned in the video that log base 10 is used a lot. So because it is used so frequently, it is called the common logarithm. And so common log is log base 10. And most of the time, it's written without a base. So it would just be written log, no base. All right. There is another logarithm that also is used a lot in science, and it's the natural log. And natural log is log base e. So that's the same e. It's Euler's number, so it's 2.71828. And it's written ln. Why do you think it's not in L for natural log? What? there's a good chance that Euler didn't speak English. And so most other languages do their adjective verb differently than we do. I mean, adjective noun. And so it most likely it's log natural because he didn't speak English. Most languages are opposite of us. All right. There is also a natural log button in the calculator. The updated calculators will do log to any base. Now, they do like to put log questions on the ACT, and sometimes they're questions your calculator can just figure out for you. Sometimes they write them kind of weird where you need to know the rules. We're obviously not going to use the calculators. We're just going to use our brains to figure it out. I can, if you're getting ready to take the ACT sometime, I can show you, remind you where the button is in the calculator. But if you remember logs, it's like at least one extra question you can get right on the ACT. Okay, so what we're going to do on example 4 is do the same thing we just did, just with common log and natural log. So we have the natural log of x equals y. So what is the base? E. So it's e. What's the power? Right. E to the y equals x. All right. And then for this one, log of c equals d. What is the base? 10. So if you don't see a base, it's base 10. So 10 raised to the d equals c. All right. And then on example 5, we're going to write in logarithmic form. So when the base is 10, we just go ahead and write log without a base. And then of t should equal s. Right. And then b is kind of confusing just because we're using so many variables. Is e a variable? E doesn't vary. E is always 2.71828, a whole bunch of decimals. So when E is the base, it's going to be the natural log of G equals F.
I thought that was a variable.
I know. It was tricky, but E is not a variable. Just like pi. Pi is a letter. It's a Greek letter, but it's always equal to the same thing. All right. So another thing we're going to do is evaluate logarithms. So when you're evaluating logarithms, try to remember that a logarithm always equals an exponent. And so you need to figure out what the base needs to be raised to get whatever the value is. Now, some things to remember while you're doing this about exponents is what a negative exponent means and what a fractional exponent means. Now, I already asked you guys about the negative exponent. So a negative exponent means reciprocal. So if you start off with a number like 5 and you want it to become something like 1 over 5 or 1 over 25, the only way to do that is a negative exponent. All right. What does a fractional exponent mean? Like an exponent of 1/2 or an exponent of 1/3? Anybody? We may not have talked about that this year. You did learn about it because we're about to learn it in Algebra 2. A fractional exponent means a root. So if you have x to the 1/2, that means the square root of x. Or if you have x to the 1/3, that means the cube root of x. Or if you have x to the, we'll say the 3/4, right? The denominator tells you what type of root it is. So that would mean the 4th root of x cubed. Now, we probably won't use that today, like the 3/4, but that is a good thing to remember. Okay, so here we go. If we want to figure out what log base 5 of 125 is, we ask ourselves, what 5 raised to what power gives you 125? What would you answer yourself? 3. That's the answer to the logarithm. Whatever the power is the answer. All right, now B is slightly trickier. This one we ask ourselves, 9 raised to what power gives you 3? It is the square root. So what power means the square root? 1/2. Very good. All right, C is a little tricky also. So we have to ask ourselves 2 to what power gives you 1/16? It's not -3, but it is negative. 2 to the third is 8. So it should be -4. So it's negative, so it changes it to a fraction. So it does the reciprocal, and 2 to the 4th power is 16. So 2 to the -4 is 16 in the denominator. All right, any questions on that? Okay, so we have some properties. Today we're only going to talk about the first property. We'll finish the other ones tomorrow. There's tons of properties of logarithms. There's actually a lot we're going to learn after Thanksgiving, but these are the 3 before Thanksgiving. All right, so I said at the beginning of the lesson that the logarithm and inverse functions logarithm and exponential functions are inverses of each other. And when we learned about inverses, I really wanted you to understand that an inverse undoes what the original function did. Okay, so if we have log base b of b to the x, so we have the logarithm of an exponential function, the logarithm should undo what the exponential function does, and it should just leave you with x because they undo each other. Right? And then the same thing for natural log. So if we have the natural log of e to the x, so one thing I didn't say is these bases do have to match for it to work. And so the base for natural log and the base for e obviously match. So what do you think you would get? Just x. All right. And then it works the other way as well. So if we exponentiate, which is my new favorite word, exponentiate a logarithm, they would also undo each other. So if you have b raised to the log base b of x, exponentiating a logarithm, it just leaves you with x. Okay. And same thing for e. So e to the natural log of x would just be x. Now those we're not going to talk about until after Thanksgiving, but we'll definitely come back to that. We'll use that a lot, actually. Okay, so let's do example 4. So we want to find the log of 1,000. And so remember, log without a base is log base 10. If I wanted to rewrite 1,000 as 10 to some power, because anytime it's 1 with some zeros, it's 10 to some power. What do you guys think that power is? 3. So however many zeros there are, that is the power. So what do you think log of 10 to the third is? Just 3. Yeah, that's what we just talked about. So when you're doing these problems with base 10 and you got a bunch of zeros, you don't necessarily have to do this. You can just count the zeros, bless you. So if the zeros are after the 1, you just count those zeros, and that's the answer to the logarithm. All right, now the next question is different. The zeros are in front of the 1. So if I wanted to rewrite this decimal as 10 to some power, what would that power be? I think someone might have said it, but I didn't hear you. Maybe not. -3. So it's still the number of zeros, but it's the number of zeros basically between the 1 and the decimal point. All right, so that's just going to be -3. So if it's log base 10 and the zeros are in front of the 1, just count how many there are between the decimal and the 1, and then negative that number. All right, the next two are a little more straightforward. So we have the natural log of e to the 4th should just be 4. Just whatever that power is. So we're just using that one right there. All right, what do you guys think D is? Just -5. That's it. All right, so your assignment today, we're going to stop there. We'll pick back up tomorrow, is on page 287, 1 through 16, and then 25 through 36.